Hello everyone, Mr. Minnick's my name, math is my game. Today in Algebra 2, it's a special day. My second period class is really stoked to be here. Uh, Today is the 28th of March. My first period class had about a 7-minute lesson. We're going to talk about this. It might take a little bit longer than 7 minutes, but not much. So here we go. Direct variation. It's a special form of a line. Okay, so when you graph these things, it's going to be a line. More specifically, it's going to be a line that has to pass through the origin. One thing I didn't tell my first period class that I'll tell you is as x increases, so does y. Now, it's kind of a slippery slope because some of these things will have a negative slope. But usually in story problems, the way direct variation goes, as x increases, y does. Sometimes not that fast, but as x increases, so does y. So if we were to picture the graph of one of these thingies, the graph of one of these, it's got to go through the origin. As x increases, as x gets bigger, so does y. So it's going to be some kind of line with a positive slope, something like that. Okay. Maybe if we graph the thing, it's going to be a little bit steeper. Maybe it's not going to be as steep, but the point is, the fact remains that when we graph this thing, it will have a positive slope. It will pass through the origin. We doing okay so far? Good. So the form of a direct variation then is written in the following way. Y is equal to k times x. Notice there's no y-intercept because the thing has to go through the origin. Okay, so there's no y-intercept. And this k has a very special name. The k is called the constant of variation. If that's not an oxymoron, I don't know what is. Jumbo shrimp. Thunderous silence. The disturbing humor. Anyway, if you need to test to see whether or not a data set is a direct variation, what you're going to do is you're going to take y and divide it by x, and each time it should equal that constant k. All right, so the algorithm, the procedure to test a table of values is to take y and divide it by x. And if that equals a constant or the same number every time, then you have a direct variation on your hands. Yeah, so if you want to test to see whether or not a table of values represents a direct variation, you're going to divide the y by the x. And it has to equal the same thing every time for every ordered pair. And also, if you're just looking at an equation, the form's got to be as such. I don't know what happened to my highlighter, but the form has to be like that. So if there's any kind of y-intercept, it's not going to be a direct variation. Okay. So let's go on to inverse variation, and then we'll look at some examples. So inverse variation. Maybe we'll do a split screen just to compare and contrast these. When you graph these, it's not going to be a line. The graph is not going to be a line. It's going to be something that's, I don't know, I'll just spell it and let you see if you can figure out how to pronounce it. It's Hyperbola. Hyperbola. When you graph this thing, it's going to be a hyperbola. This thing will not go through the origin ever. It can't. By design, it's not able to go through the origin. With direct variation, as x increases, so does y. With an inverse variation, as x increases, guess what happens to y? Y decreases. Good. Y decreases. Now, the part about this that's unusual is that when we get to the negative x values, I can't believe I just, oh, that's a y, okay. Just looking back at my graph, my one y looked like an x. You know, I haven't used Carlton in a while. I don't know how this is going to turn out in the video, but I think we deserve to have a look at Carlton. Because these hyperbolas, they're unusual. Let's see if the music plays. It probably won't. Yeah, that music's probably going to turn out horrible in the video. All right. So the hyperbola, when you graph it, some of the graphs, if I'm being honest, they're going to look like they belong in health class rather than math class. So as x increases, y decreases, the graphs are going to look like this. There's going to be some what's called branches, and we'll study these again on Thursday. There's a branch in the first quadrant that kind of looks like that. And then there's a symmetrical branch in the third quadrant that's going to look like that. Okay? So regardless of where you're looking, as x increases, y decreases. Okay? Question? Do they always reflect over the origin? Yeah, if you want to think about where they're symmetric to or what they do, they're actually reflections about the line y equals negative x. They actually are reflections across there. Really good thought. Yeah. Great question. So the form then for an inverse variation, the form here, starting with a y, is going to be y equals k divided by x. Y equals k divided by x. And again, the k is called the constant of variation, which, again, to me, the constant of variation seems like an oxymoron. Anybody have any other good examples of oxymorons? Led Zeppelin? I'll have to think about that one. Explain. How's Led Zeppelin a little not? Because that's good. Because lead is dense, and a hot air balloon would float, and that's what a Zeppelin is. I like that. That's good. That's real good. The spelling, I guess, got me. Yeah, but that's good. Awesome. So the form of this, or if you want to test to see if a table of values is an inverse variation, it's a real simple test. You're just going to multiply the x and the y values. And again, they have to equal some constant. So in the exercises, you're going to see what you're going to have to do is test to see whether some ordered pairs represent a direct variation or an inverse variation. And it's real simple to test. Are there any other questions before we get started with those examples? Yeah, so the question's about when you test. When you test, you're going to need to run two separate tests, one for direct and one for inverse. Yeah. For inverse, yeah, you'll get the same value every time you multiply x by y. Yeah. You'll get the same value every time you multiply x by y, if it's inverse, actually. The k and the y kind of switch places. You can think of it that way. Yeah. So let's get to example numero uno, and maybe this will all make more sense. Example 1 is each equation a direct variation? I'm going to abbreviate. Sorry for the abbreviations. Inverse variation or neither? Question mark. Is this a direct variation, an inverse variation, or neither? If it's a direct variation, write the equation. If it's an inverse variation, write the equation. And identify the constant of variation. The k value, if you would. So here we go. Number A, number B, numbers. I know A, B, and C and D aren't numbers. The constant of variation. Why did I go A, B, C, D? That's a good question. D, there we go. So let's look at y equals 6 minus, 6 plus x. 1 over x equals y. Y equals 1, y equals x over 10. That's a good one. And xy equals 3. Those are all pretty good. So let's look at number A first. Is that a direct variation, an inverse variation, or neither? neither. Why do we say neither? Because there's a 6 right here. That 6 is a y-intercept. That means when we graph that thing's going to go through the point 0, 6, and it's going to be a line with the slope of 1, and it doesn't go through the origin, so that one's neither. Okay. Anytime a linear equation has a y-intercept other than 0, it's not going to be a direct variation. Okay. What about number B? What do we think about that? Well, it's either direct or inverse. So inverse, okay. So this one is inverse. So what's the equation? One over x equals y, or y equals 1 over x. And what's the constant of variation? 1. There we go. Good. Looks like a number C. This one is sneaky to a lot of people. Some people see a fraction and they automatically assume one thing. What do you think? The constant of variation is simply the coefficient, the number. If you compare number B to the form that we just saw, let me get some boxes going here. If we compare number B to this formula that we just saw, the constant of variation is the k, and the k is kind of like just the number that's going to show up in the equation. Okay. All right. Good question. So back here then, what's number C? What do we think about that one? I heard neither. It's not neither. It is direct. You see the fraction, you might think it's inverse, but this one is direct. This one is a direct variation. The equation is y equals something times x. Maybe it's a little bit easier to see if you put a 1 up here next to the x. So what's the slope of that line? What is it? 1 over 10. Nice. Good. So the slope's 1/10. So what's the constant of variation then? 1/10. And finally, number D. What do we think? Direct, inverse, or neither? I'm hearing neither. It's not neither. It is inverse. It is an inverse variation. What's the equation? Remember, the form for inverse has got to be of the form y equals some number divided by x. Y equals 3 over x. And the constant of variation is 3. What do you think? I'll be frank with you. This is the easiest lesson we're going to have the rest of the year. Oh, you're hearing a boo. Example number 2. Identify each as direct variation, inverse variation, or neither. If direct or inverse, write the equation and identify the constant of variation. So the same thing, but instead of giving you an equation this time, I'm going to give you the table of values. So here's x, here's y. I like this. We got the number 4, and then that number, and then 5, and then that number, and then 6, and that number, and then 7, and this number. So I know some of you think you got this one figured out, but you got to be careful. Remember that oxymoron. It's a constant of variation. You know what the word constant means? Not changing. So let's check to see if this is direct, inverse, or neither. If we wanted to check to see if it's direct variation, what's the test for direct variation? You do what? Bueller. Divide y by x. So we're going to divide y by x, and it has to equal the same thing, not once, not twice, every time. It has to equal the same thing every time. So 20 divided by 4 is how much? 5. And 25 divided by 5 is how much? 5 again. And 30 divided by 6 is how much? Now at that point you might think to yourself, this looks like it's a direct variation. However, it has to hold true for every ordered pair given. 49 divided by 7 is not 5. It is 7. It's not 5. So the point is, this is not a direct variation. to test to see if this is an inverse variation. What's the test there? We find the product. We say x times y. So 4 multiplied by 20 would be 80. Okay. We might not have to go that far. 5 times 25, 125, or not 80. That's it. We're done. So what's our answer here? Neither. So this one's neither, neither. How we doing? Okay. So what if we had something like number b, x, y, 1, 0.3 repeating, 5, 1.6 repeating, 15, 5. What if we had something like that? Well, let's see. Inverse variation, we're going to have to divide 0.3 by 1. Multiply. Well, let's try direct variation first. 0.3 divided by 1, 1.6 divided by 5, 5 divided by 15. That's not it? You sure? Let's see. Point 3333333 divided by 1. Okay. 1.66666666666 divided by 1, or divided by 5. Oh! And 5 divided by 15. Oh! Oh! We didn't think it was anything because I don't know why. But anyway, so the deal is that quotient is the same, isn't it? So our constant of variation is whatever that quotient is, and so this is a direct variation, right? Of the form y equals 1/3 times x. Got him? That's it. It's been real. It's been fun. I'd like to give a shout out to the future Mr. Minnick. I'd like to give a shout out to Mr. Joshua Forsyth. Shout out to Travis Sinisvet. And a shout out to everyone who asks questions. Have a great day. See you next time. God.